all of you. Please be very attentive. If you could relate to these four structures of four geometrical isomers. Suppose I decrease the number of carbon atom by 1. If I decrease the number of carbon atom by 1, ठीक है? Then I suppose decrease it from here and here as well. ठीक है? Now still it's a cis trans, and this is a trans-cis geometry from left to right. Suppose if I watch it from right to left. Now if I watch it from right to left, then it's cis trans, and it's the same as this one. It's the same as this one. Take your time. Before this, counting from left and right would have been two different situations, because the molecule was not symmetrical. The two ends were not similar. But if I take out this carbon atom, now this left to right is cis trans, but right to left it's trans-cis, which is the same as this structure. So now the number of geometrical isomers is not 4, it's 3 only, because these two are same structures. But if again I go back to the initial state, where the two ends are dissimilar, then cis trans and trans-cis are different structures. Fair enough? Is that understood by all? So it's going to be 2 to the power n. Exactly only if the two ends of the molecule are dissimilar. If the two ends of the molecule are dissimilar, because if the ends are similar, you can count from left or right. Now again, if the ends are similar, you can count from left or right, and as you see in this case, a cis trans is going to be the same as trans-cis. If the two ends are similar, you count it from left or you count it from right, it's the same molecule. If it's not dissimilar, then they are two different molecules, and in that case you can't see it from left or right both, because you'll always want to name it and take it as a compound, or you'll want to again always number it so that you have the smallest sum rule obeyed in nomenclature. So for n different pi bonds, 2 to the power n, only if the ends are dissimilar. If the ends are similar, these two overlap, it's not going to be exactly 2 to the power n. If the two ends are similar, number of geometrical isomers will be, take down these two results, it's going to be 2 to the power n minus 1 plus 2 to the power n by 2 minus 1 if n is even, and it's going to be 2 to the power n minus 1 plus 2 to the power n by 2 minus half if n is odd. So you'll want to recall these two results. Number of geometrical isomers is 2 to the power n, now only if the two ends are dissimilar. Otherwise you'll have various structures overlapping. The number of structures will be less than 2 to the power n. You'll want to recall these two. Now these two are if the two ends are similar. 2 to the power n minus 1 plus 2 to the power n by 2 minus 1 if the number of pi bonds is even, and n by 2 minus half if the number of pi bonds is odd. And you'll want to recall this result. In case they end up giving you a big molecule, it's going to come really handy. Let's move on then. Maybe take a small break, small breather, go through everything, let me know if you have a doubt, and then I'm going to give you a brief introduction to optical isomerism. Fine.